Now, in question number 9, the question says that a solid circular cylinder has a base radius of r centimeter and a height of h centimeter. The cylinder has a volume of 1200 pi and a total surface area of s centimeter square. So we want to show that s is equals to 2 pi r square plus 2400 pi over r. So let's start with finding the surface area of this circular cylinder. So surface area of the circular cylinder. So circular cylinder is divided into two parts. You have the circular base, which is available on the top and bottom, and you have the curved surface on the side here. So the circular base would be 2 pi r square indicating the area for each circle and multiplying by 2 because there are two circles. Then plus the area of this side is basically just a rectangle, but it's going to be height multiplied with the circumference, 2 pi r. So therefore 2 pi r h. Okay, now the problem with here and the question is that this doesn't have any h, right? But in your equation it does have h. So what we're going to do is we're going to use the volume which is given to you, and the volume of a cylinder would be equals to pi r square h. Okay, now if volume is 1200 pi and pi r square h, and you want to make h as a subject, so we can cancel this pi. H is equals to 1200 over r square. Now let's substitute this h into the s equation. So s is equals to 2 pi r square plus 2 pi r, then h is 1200 over r square. So we have 2 pi r square plus 2400 pi over r, and then shown. Okay, so now let's move on to the next part 2. So in part 2, given that h and r can vary, find the stationary value of s and determine its nature. Stationary value of s, so we have s is equals to 2 pi r square, right, plus 2400 pi r to the power of negative 1. Since we want to find the stationary value of s, we need to find the stationary value when it was ds over dr is equals to 0, right? But we need to find the value of r first. So ds over dr is going to be equals to 4 pi r, then minus 2400 pi r to the negative 2. So instead I'll write this over r square. So then ds over dr is equals to 0. So we'll have 4 pi r. I'm going to skip some steps here. After I substitute ds over dr, I'm going to move this expression to the other side. So we have positive 2400 pi r square. Okay, so now next we'll have 4r cubed is equals to 2400, then r cubed is equals to 600, then r is equals to cube root of 600. Okay, so now we found the value of r, we can find the stationary value of s. So s is going to be equals to 2 pi r. Okay, let's just substitute everything here and find the final answer. And your s is going to be equals to 1, 3, 4, 0. The 3 is significant figure. Okay, but this is just the value of s. We need to next determine its nature. So our second point here, let's bring it to the other side. So we take the ds over dr, okay, and then we change it. We're trying to find the d2s over dr square because we're trying to find nature of stationary point. So we'll get 4 pi plus, that's going to be 4800 pi over r cube. Okay, so we already found the r, which is cube root of 600, and what we're going to do is we're just going to substitute it into this expression, and then our answer is 12 pi. So 12 pi is actually more than 0, so therefore this is a minimum point. Okay, and that's your answer.